Hey guys, today we're going to take a look at one of my favorite problems. It's abstract, it's oddly phrased, and in fact, the hardest part for many folks on this problem is simply understanding what's being asked for. The difficulty is that it's written in math speak. It's written in that very abstract clinical language that, if you haven't studied advanced math, might be new to you. How this breaks down is they're giving us this product from 1 to 30, which is the same as 30 factorial. 30 times 29 times 28, all the way down the line. Or you can build it up, 1 times 2 times 3 times times 29 times 30. And then they're asking this crazy thing about how many k such that 3 to the k. What they're asking here is how many factors of 3 are embedded in this massive product. That's the hard part. Figuring out how many there are, once you have an algorithm or a system for it, is fairly straightforward. If we lay out all our numbers from 1 to 30, and we don't want to sit there and write them all, but just imagine that number line in your head. 1 is not divisible by 3. 2 is not divisible by 3. 3 is. 4 isn't, 5 isn't, 6 is. In fact, the only numbers in this product that concern us are those divisible by 3. 3, 6, 9, 12, 15, 18, 21, 24, 27, 30. Here it's important to note that each of these components, except the 3 alone, has multiple prime factors. The 3 is just a 3. The 6 is 3 and a 2. The 9, notice, has a second factor of 3. 3 times 3 is 9. And because we're looking at the prime factors, it has 2. And it's difficult to get your head around, but there are not 3 factors of 3 in 9 when you're counting prime factors. 3 factors of 3 would be 3 by 3 by 3, 27. So notice that 3 and 6 have a single factor. 9 has a double factor. Every number divisible by 3 has 1 factor. Those divisible by 9, like 9, 18, and 27, are going to have a second factor. And those divisible by 27, that is 3 cubed, are going to have a third factor. If we lay it out like this, we see 10 numbers have a single factor. Another of those 3 provide a second, bringing us to 13. And finally, 1 has a third, bringing us to 14. Answer choice C. So let's take a look at this problem by writing a new one, just to reinforce the algorithm. For the number 100 factorial, how many factors of 7 are there? So first we ask ourselves, out of the 100 numbers, which ones even play? 7, 14, 21, so on and so forth. 100 divided by 7 equals 13. So there are 13 numbers divisible by 7 from 1 to 100. Of those, how many have more than one factor of 7? Well, we know that 7 squared is 49. So only those numbers divisible by 49 have a second factor. 49 and 98. There are none that have 3 factors of 7 because 7 cubed is 343. If you don't know it, that's an identity you should know. So here our answer is 13 plus 2, 15. Try a few more on your own. This one's great to do as a problem form. And take a look at the links below for other abstract number theory, counting prime type problems, as well as a selection of other really fun ones. Thanks for watching, guys, and we'll see you soon.